before we get started into the talk, we'll have Joanne Whitfield do a land acknowledgement.
Sego, Annie Bozo. Hello, everyone. Joanne Nadishnikas. My name's Joanne. I'm speaking to you from Cataraqui, also known as Kingston, located in the territories of the Haudenosaunee, the Anishinaabeg, and the Huron-Wendat, where the waters of Lake Ontario, the St. Lawrence, and Cataraqui rivers meet, one of the most beautiful and sustaining places on earth. Little Forest Kingston recognizes the inherent sovereignty of these First Nations to this land. We are fortunate and thankful. They are cultures rooted in resilience and generosity, alive and thriving today to provide us with a model of harmony and balance with and in nature. Anishinaabeg and Haudenosaunee worldview helps us understand that we are the younger brothers in creation. They have always understood that we must extend our notions of personhood beyond the human, to the plants, to the insects, to the waters, to the rocks, to everything that makes up the natural world, wherever you find yourself on Turtle Island. We are grateful for their invitation to join the Dish with One Spoon Treaty and Wampum Protocol. We acknowledge the other original inhabitants of this land who have never forgotten their duties and responsibilities, the more than human beings who have suffered from the colonial mindset that continues to dominate this place. Most especially, we want to acknowledge the photosynthesizers who can make matter from the power of the sun. Plants are the world makers, the oxygen creators, the soil holders, the water purifiers. They are the ones who daily make the planet livable and breathable for animals like us. They can be our teachers if we open our hearts and minds to their lessons. Locally, we encourage you to donate to the All Our Relations Land Trust and the Indigenous Food Sovereignty Garden, who are the 2024 Kingston Community Climate Action Fund project. Money donations will help them install solar panels to support the restoration and regeneration of that land. They also welcome volunteers eager to develop a relationship with the land and its inhabitants and to learn more about All Our Relations. How lucky we are to have their model of land care and land relationship here in our midst. Chi Miigwech, Nyawe. Thanks, everyone.
Thanks so much, Joanne. Okay, so welcome everybody. It's wonderful to see such a great turnout of people to come and listen to Oliver's talk tonight. I'm just going to give a brief introduction into some things about Little Forest Kingston. So my name is Chloe Wilson, and I'm part of the group. We're a nonprofit organization here in Kingston. And if you go to our website, which is littleforests.org, you can see our vision is to transform Kingston into a nature-positive, equitable city in a forest by 2030. So we do that, or we're working on that primarily by planting little forests around the city and sort of related projects. So some of this is sort of larger forests on public or private land. And also we're encouraging people to plant little forests in their yards and related types of biodiversity projects like pollinator gardens and things like that. So how this talk came about is that I'm part of a group called the Wranglers. We're a node of the Little Forests Kingston organization. And our name is kind of like a cute description of what we do. We kind of try to wrangle little trees into forests and care for them in their formative years. I guess more specifically, we do a lot of choosing and sourcing trees in conjunction with the project teams. And we always want to understand more about how we can do that, how we can choose species that will thrive and be healthy, and how we can best care for these forests and plan for them. And so, what's I going to say next? Yeah, like part of what we do is trying to learn as much as we can in order to do that. So we're trying to incorporate talks like the one that we're having tonight, so that we can learn from experts, and then we also want to share it globally as much as we can. So everything that we're learning, we'd like to share so that we can plant seeds and create mycelial networks and collaborate, and everybody can learn more about this. And ultimately, more and more trees can be planted and more forests can come into existence. So just some logistics for the meeting tonight. Oliver is going to talk, I think, for around 30 minutes, and then we would definitely like to have a Q&A session. So if you have questions that arise while Oliver is speaking, you can just type them into the chat in Zoom. And then when Oliver's done, I'll read the questions and we can discuss them afterwards. And yes, just please keep your microphones muted throughout the meeting. That would be great. And then, yeah, we have a website. I think I mentioned littleforest.org. So if you'd like to go learn more about us, you can go there, and you can always sign up for our newsletter if you'd like to keep informed about when we're going to be having talks like this, because it is something that we're sort of hoping to do on a semi-regular basis. Okay, so on to our talk for the evening. We are fortunate to be having Little Forest Kingston's own Oliver Reichl. He's a board member of our organization, and he's a consulting arborist-ecologist. So he's very qualified and educated in this field, and anyone who knows Oliver knows that he's very passionate about all of these kinds of topics. So we're really excited to have him tonight, and I hope everybody enjoys this. So with that, I will just pass it over to Oliver.
Okay, thanks, Chloe. Hope everybody can can hear me, for one thing, and secondly, that you can all see a lovely sunny view on your screens, because that's about to change to include a title. Uh-oh, I got my first issue already. Hold on, let me try something else here. That's not going to, there we go. All right, so this is basically going to be a really brief sort of introduction to the ecology of the Thousand Islands. We could probably spend all day on this kind of subject. Ecology is a very big topic, but I am not going to assume that it is something that all of you are intimately familiar with. So we're actually going to spend a little bit of time just introducing it first. So, and as Chloe said, this is a presentation by me. What I'd like to do over the next little while is give you, first of all, we're going to do a quick little bit of Ecology 101. I'm going to touch on 3 or 4 of the more important concepts of ecology, and then we're going to see how they manifest themselves here in the Thousand Islands. We're going to have a look at the larger landscape before we zero in on our subject matter here, just to give the Thousand Islands sort of some context. And then, of course, we will get right into the Thousand Islands and some of the more unique features that are here. We'll have a look at how those features have a pretty significant influence on biodiversity here. And I'll wrap it up with some final thoughts on that. And then we'll have a little bit of Q&A. All right, so Ecology 101 here. For those who are not familiar with what ecology is, it's essentially, it's kind of like biology, but it goes a little bit further. It's actually a whole bunch of ologies in one, because not only does it take into consideration living organisms and the environment, but it is basically the study of the interrelationships among them. So, and tries to understand the connections between plants and animals and their environment. So, basic concept number 1. Now, all of us probably learned this first one way back in school, the concepts of food chains and food webs. Food chains are kind of simplistic, generally linear, but an example of a food chain basically describing who eats who or what eats what. So we might, an example here would be something like a mouse eats the seeds of a plant, the mouse gets eaten by a snake, the snake gets eaten by a hawk. Of course, nature is not this simplistic. In the real world, out on our ecosystems, we tend to have what are referred to as food webs. So there are multiple interrelationships among multiple organisms. And this is just a graphic I found online that kind of, well, at least gave some examples of animals that, you know, we're familiar with here in this area. Food webs are very much dependent on habitats and the diversity thereof. Once you have habitat diversity, you'll have corresponding species diversity. And with greater species diversity, you're going to increase the complexity of these food webs. This is going to be my my only shill for a book. It's not even mine, but this is, if you're interested in these kinds of relationships, particularly the food webs and food chains here in North America, this is a really good book. You can look up a plant and you'll get an idea of, and it'll tell you what eats it and what percentage of their diet makes it up. You can also look up an animal and it'll tell you, it'll go the same route with plants. So it's not a new publication, but it's still out there, and you can order it on Amazon or wherever you buy your books. Concept number 2, microclimates. So microclimates rely an awful lot on a couple of conditions that occur in the environment, those being slope and aspect. Let's deal with slope first. Here's a typical hill sticking out of the landscape. Obviously, this hill has a slope to it. Generally, where we're concerned about in ecology and the importance of this is that we all know that water moves downhill. So, basic rule is that the top of a slope will be drier and the bottom of the slope will be wetter because, as I said, water flows downhill. The other part of this, the other aspect, is aspect. And in this sense, we're referring to compass directions, or basically which way is north. So everything I'm about to tell you about aspect and its ramifications here, bear in mind that this would apply to the northern hemisphere, and if we were in the southern hemisphere, I would assume we have to reverse this. So I'm going to give you an example here of something we're all familiar with, basically a building. So whether it's your house or, in my example, we're going to use Joe's garage. Joe's garage happens to be situated in such a way that it's oriented exactly along the cardinal points of the compass. How does this affect Joe's garage? Well, we can say that, first of all, the north side, primarily the north side, and to a lesser extent, the eastern side of Joe's garage are going to be cooler and wetter. North side, pretty obvious. That's the side that never gets any direct sunlight. East side, well, it'll get some direct sunlight in the morning, but by noon, that's all over. So conversely, the warmest part of Joe's garage is going to be the sun-facing south side, and to a lesser extent, the west side. So the west side will also be warmer. You might wonder about that. You know, well, the sun doesn't actually shine on there until the afternoon, but the west side has had all day to warm up ambiently, even if it's got no direct light. So by the time the light is on there, it actually is a little bit, it's actually relatively warm already anyways. So with this kind of model in mind, let's take a look at the natural environment, because this phenomenon of slope and aspect is what we're talking about here, will manifest itself pretty much in all manner of life forms and landforms. So it doesn't matter whether we're talking about a mountain, smaller hills, even islands, something as small as a rock outcrop, the ditch in front of your house, or even an individual tree. An example of how aspect manifests itself on trees is that at this time of year, trees will sometimes form frost cracks. When there's too much, when things warm up a little too much during the day, so the tree is really warm on one side and relatively cold on the other. All right, so that takes care of slope and aspect. Number 3, plant succession. This was something that I touched on in a previous talk that I gave to Ontario Naturalists a few years ago. Plant succession is basically a concept for how vegetation communities change at a given location over time. So if we start off with a barren piece of rock, the first things that are going to colonize that are going to be lichens and mosses. Next up would be grasses. Once we have a little bit of soil development having started and a place for roots to anchor themselves, those will graduate to shrubs. The first trees will start to show up. These would be, when we talk about intolerant trees, these would be trees that are intolerant to shade. So they need full sunlight. Birches and poplars are a couple of examples. Those will slowly get replaced by what we call trees of intermediate shade tolerance. Example here being white pine. And eventually we end up with what's called a climax community of shade tolerant trees where young trees can grow up in the shade of their parents. So in addition to abiotic factors or non-living factors like slope, aspect, and that sort of thing, we find that vegetation over time also contributes to microclimates by the amount of shade that's created. This process of plant succession can be set back by a disturbance. A land developer can pretty much set a property all the way back to barren. Fire will often do the same thing. Logging is another typical disturbance. Every time you cut your grass, you're disturbing this successional process and keeping it in the grass stage. So there are a lot of other things, though, that happen and manifest themselves over time in these communities as succession takes place. So here are some of them. I'm going to give you all a moment to have a quick glance at this list. From this list, I'd like to just concentrate on a few of them. The very first one, food chains, which become more web-like as the vegetation community becomes more complex and has its own sort of trophic levels with an understory and overstory and that sort of thing. The amount of organic matter increases. The amount of species diversity, both in terms of abundance and richness, increases. Size of the organisms increases. Life cycles become longer and more complex. The stability or resilience of these ecosystems to changes becomes better. And as I'd already mentioned, the microsite temperature becomes a little bit cooler as the trees start to shade out the understory. We have more humus developing, and of course the plants that are tolerant to shade, they also become more dominant. I just have a quick question to the other host here. If I'm waving my mouse pointer around, do people see that?
Yes.
Okay, good. So that means I can use it as a pointer. All right, so succession, in the sense that I just described it, often pretty much occurs at one location over time, but this continuum of lichens to grasses to forbs to shrubs to intolerant trees, etc. This, to some extent, also manifests itself over altitude and latitude. So, for example, up on the tundra, we pretty much will only have lichens. There's a tree line beyond which woody plants really don't grow much anymore. This brings, topic number 4 here in terms of basic concept is the concept of an ecotone. Ecotones are the technical term for something that is really transition zones. So if you have two ecosystems, one beside the other, there will often be a transition zone where these two systems overlap. Sometimes it's more gradual, sometimes this transition is rather abrupt. Another term for this kind of area is that I've heard of, these are called edge habitats. So the edges of a clearing would maybe be one example. Ecotones also happen at very large and very small scales. Remember, as I just mentioned about altitude and latitude, this particular graphic shows very, very large landscape scale ecotones where different forest regions change as latitude changes. And again, like I said, to some extent, this happens with altitude too. If you've ever been in the mountain, in a mountainous region, and you're in the valley, you'll see that the vegetation in the bottom of the valley is quite different from, you know, what happens as we move further up the top of the mountain. Here's a more simple conceptualization of how this manifests itself. So let's say, for example, here's the importance of ecotones. We have two ecosystems, ecosystem A, ecosystem B. Each ecosystem has a certain number of species that are in it. Species from both will occur in the area where there's overlap. That pink area in between, that's our ecotone or our transition zone. More importantly, however, there are species whose primary habitat is these transition zones. So the transition zone is really, there's sort of a symbiosis going on here. In other words, you know, there's more, it's more than just A plus B. So we kind of get A plus B, and then there are, in this ecotone, we will have species that really only thrive in there. So in other words, we have a greater amount of diversity or concentrations of diversity in these areas. Alrighty, so much for basic concepts. So let's zoom out for a second, have a quick look at the larger landscape, and give the Thousand Islands region here some context. So here's a quick picture of southern Ontario. I'll briefly mention the elephant in the room here, which is the Big Fat Lake to the west of us. That is Lake Ontario. Obviously a very dominant landscape feature in this part of the world. Like all large bodies of water, what Lake Ontario does is it, well, because it's a large body of water, what it does is it heats and cools slower than the surrounding land, and therefore exerts a modifying influence on it. On the land side of things, there are, if you look at southern Ontario kind of overall, there are, in terms of natural systems, there are three, you know, large scale natural features of great significance in southern Ontario. I'm sure we're all familiar with all of them. Number one to the west is the Niagara Escarpment, and that's my little dark green area over there. Connecting with that and roughly perpendicular to it is the Oak Ridges Moraine. And in our area out here, we have this little thing called the Frontenac Axis, which is basically Canadian Shield. The brown area, as you can see here, we have the Canadian Shield and the axis connecting to the Adirondacks. The Adirondacks are also still Canadian Shield, but the important thing that we want to focus on is this large-scale landscape feature called the Frontenac Axis, which cuts more or less perpendicularly across the St. Lawrence River right here in the Thousand Islands. There was briefly mentioned a couple of organizations. I remember a number of years ago hearing of an organization called NOAA, was sort of an acronym of NOA for Niagara and Oak Ridges and Axis. So basically an organization that was trying to sell the importance of these three landscapes, and perhaps work on, you know, more connectivity between the axis and the moraine. As you can see, there's kind of direct connectivity between the moraine and the escarpment, not so much out this way. Anyways, NOAA seems to have gone away. Even on the Internet Archive, the Wayback Machine, the only thing it remembers of the NOAA website is the robots.txt page that site had. More importantly, an organization that is still around is called the A2A organization, which basically translates to Algonquin to Adirondacks. So this large-scale corridor that is formed, where the axis connects the Adirondacks, like I said, to the Canadian Shield, and specifically a large natural area, Algonquin Park. That is their focus, and I think the A2A organization is still out there and working on this connectivity. Alrighty, so the Thousand Islands. We're going to zoom in on this particular area right here. So the upper end of the St. Lawrence River, east end of Lake Ontario. There is debate about where Lake Ontario starts and the St. Lawrence River begins. One of the things that I noticed as I was putting this particular talk together is that we could kind of look at the Thousand Islands and this area of the river as our first transition zone, sort of a large landscape level ecotone where the aquatic ecosystem is changing from a lacustrine to a riverine system, or in layman's terms, as it changes from a lake to a river. And that, of course, is all right in here. If you want to see where the river really starts to move, and you can see that it is a river across the Thousand Islands Bridge, you can really see underneath there where the water's moving. The river almost never freezes underneath there. So we actually have water movement in that area. So a gradual ecotone from lake to river over a span of maybe the first 30 or so kilometers of the St. Lawrence. Things haven't always been this way. If we go back about 17,000 years ago, 15,000 years ago, everything was covered by a kilometer thick hunk of ice called the Laurentide ice sheet. Now, as the last ice age came to an end about 12,500 years ago, and this ice melted back, the first thing it formed was a glacial lake called Iroquois. And then as that drained, a smaller lake called Admiralty Lake. But I don't want to spend too much time on this, but have a look at the picture on the left. At the top, we have modern Lake Ontario. Note the dashed line for mean sea level. So look how high up we are now on mean sea level. And then let's go to when the Champlain, so basically the Gulf of St. Lawrence and the Champlain Sea, we can see extended actually as far in as the Thousand Islands. And mean sea level was significantly lower. At that time, the Niagara River still drained into this Admiralty Lake, but that lake did not drain out through the St. Lawrence. The St. Lawrence River, as we know it now, didn't actually exist. The main flow of water or source of water for the Champlain Sea was the outflow of the glacial Trent River. So what happened? How did this change of elevation come about? Well, we have to sort of picture the Earth as being sitting on a sea of molten lava, which of course is the mantle underneath the Earth's crust. The Earth's crust is made up of tectonic plates. The plate that is here was weighed down so much by the sheer volume of ice on top of it at the Ice Age that it actually pushed this continental plate downwards, leading to this roughly what we see here in this drawing in number B. When the ice melted, and as the glacier receded and things started to warm up, we had sort of this land bouncing back up. And this is the technical term for this process is isostatic rebound. And that is a process that is still going on today, albeit at a much slower pace than perhaps it was for the first few thousand years after the end of the Ice Age. So nowadays, of course, as we know, we have water flowing out past Brockville, down the St. Lawrence to the Gulf, where when the estuary from the Champlain Sea was once, west of Grenadier Island or west of Mallory Town, the estuary is now, for the Gulf of St. Lawrence, the estuary is now around where the Saguenay River exits into the St. Lawrence. So several hundred kilometers easterly in Quebec. All right, so we have this gradual change from lake to river. One of the effects of the lakes, of the Great Lake, as I mentioned, is that it has this moderating influence on the climate. So things tend to be a little bit warmer here because of the influence of the lake. And this manifests itself in less extreme temperatures, more degree growing days for plants. For animals, we have a number of species that are more common southerly, but their northernmost range dips into Ontario here and basically gives them the northern limit of their range. So these are kind of, for biologists in this area here, so the rock star species are things like pitch pine, deerberry, black rat snakes, that sort of thing. But the emphasis here at the moment is this moderating influence of the lake. So let's overlay the axis onto this. This is just a stylized thing that I drew on here. It's sort of, let's consider it more conceptual than dead accurate. So what does the Frontenac axis do? Well, it cuts across here, and what it has created is as we move from Kingston to Brockville, we have some abrupt changes, and again, ecotones based on bedrock. So very fairly abrupt changes in the bedrock as we go from westerly to easterly. Bedrock affects soil chemistry, and soil chemistry affects the kind of plants that can grow on it. So as I'm sure we're all familiar, for those of us who grew up in Kingston, so to the west of the axis, we have limestone. Limestone is a sedimentary rock, quite calcareous. So in other words, good at buffering acid, so soils tend to be less acidic. To the east, this is a spot along the Thousand Islands Parkway, somewhere right around Browns Bay, so east of Mallory Town. We have sandstone, so another type of sedimentary rock, but whereas limestone was old bedded, used to be kind of what could be considered lake bed or seabeds, sandstone would be more old, very, very, very old beaches. And as we know, in the middle, we have this Precambrian shield, this granite. One of the best places to see this granite stuff is right by is the turnoffs and turning circles around the Thousand Islands Bridge, which is where I got this little street view grab from Google. So how does this manifest itself here? Well, the Thousand Islands, at least a goodly chunk of them are also composed of the same ancient granite. And if we drained all the water out, we'd find that we actually had 1,000 hilltops here. So the islands are really just the tops of the mountains surrounded by water. This ancient mountain range is part of very, very, very old mountains that extend kind of all along, to one extent or another, along the eastern coast of North America. And depending on where you are, these things will have different names. For north of Ottawa, it's the Gatineaus. Further east in Quebec, it's the Laurentians. On the American side, it's the Adirondacks, and so on. So we call them the Thousand Islands, but we could really look at them also as 1,000 ancient granite mountains. These things will have ramifications for even inland. So whereas the islands are, well, the hills are these rock outcrops become islands in the river. On the adjacent mainlands, they kind of become, think of them as sort of forested islands in the middle of patchy cultivated areas where we try to do some farming. Really, the Canadian Shield and the Frontenac axis is not particularly good farmland, which has worked in the environment's favor here because it's kept things in a relatively natural state. But in this aerial photograph, you can see here is like there's all these little forest islands where these same rock outcrops stick up above the more lowland flat areas. This kind of environment, and I've already mentioned the A to A corridor, Adirondacks to Algonquin. This makes things very suitable to migration. Large bodies of water like Lake Ontario pose a significant barrier to migration, even to birds. So animal movement is facilitated here by the islands, which kind of serve as stepping stones to hop, skip, and jump across the river. The eastern side of Lake Ontario here, again overlapping this, there's one arm of the Atlantic Flyway, major migration route for migrating birds, also cuts through here. So we have a migration corridor. On top of this, these abrupt transitions in bedrock and the gradual transition in aquatic system, all being moderated by the Great Lake westerly of us. Yeah, so from a migration point of view, we can also think of the islands as 1,000 stepping stones. This was how, non-flying mammals and animals in general find their way north. The only thing I've ever seen swimming in the river is a raccoon, so I do know that things will swim. Where things freeze over, animals can cross this land bridge in the wintertime. Some of them will occasionally, I suppose, even use our own bridges that we've created. But this is yet another way that we can think of the Thousand Islands as 1,000 stepping stones. Unfortunately, these 1,000 stepping stones also work for invasive species. So that's kind of one little drawback, so that invasives that may have started in the States can also find their way in here as they move north. I don't think we won't necessarily see that with oak wilt, but in the past we have seen that with gypsy moth and Dutch elm disease. So, which brings us to trees. All right, so let's zoom back out again to a landscape level. We have in Canada a number of what we call larger forest regions. The single largest, most dominant one across the country is the boreal forest, which I assume everybody's heard of. There are numerous other regions around, though. The one that's important to us is the one that shows up as lime green in this picture. the Great Lakes St. Lawrence forest region. This is a forest region that sits between the light blue one at the bottom, southwestern Ontario, which is Carolinian forest, and the more northerly one in Ontario, which is the boreal forest. So again, what we have here in the Great Lakes St. Lawrence region, which the Thousand Islands are a part of, we have another transition zone. So again, a larger landscape level ecotone. In this case, we're talking about a transition zone between Carolinian and boreal forests, and the tree communities and assemblages, that occur in each one. So here in the Thousand Islands, we are in a forest transition zone, a zone transitioning from Carolinian to boreal. So while in the Thousand Islands, we'll see things like boreal species like tamarack and jack pine and balsam fir, but we will also find Carolinian species intermixed and growing among them, things like hickories and butternut, as just a couple of examples. Now, this transition zone, this transition thing has been around for actually quite a while. Early on, though, as the glaciers retreated, our plant communities went through changes kind of similar to what we see at the latitude level as we head further north. I'm going to take a minute to explain this particular picture. What we're looking at here is an analysis of a pollen core taken at Boyd Pond, New York, kind of close to this area here. We had another one closer to the area here from Hill Island. However, I'm going to use this one because it graphically works better to explain sort of the general sequence of events that happen. If you look along the far left y-axis, you'll see the numbers 0 to 9. That's meters in depth. So as we go towards the bottom of this drawing, we are going further back in time. As we go towards the top of the graphic portion, things become more recent. You look at the far right side, you'll see it says pollen zones. And the only thing I'm going to say about that is zone 1 is considered to be where when Europeans arrived. What we're looking at here is this is an analysis of pollen grains. So from these cores that were extracted from peat bogs, they looked at pollen grains, and pollen grains, just like leaves and bark, are a feature of plants, and pollen grains are all rather distinct in how they look. And we base our thinking by looking at the relative quantities of pollen and the species that the pollen came from to give us kind of an idea of which species and the abundance thereof occurred at certain times. So I'm going to use my pointer here a little bit. Down at the bottom here, below pollen zone 7, so the ice has left and things are warming up. So what would have at very first have been tundra very soon gave way to vegetation assemblages that are very reminiscent of the boreal forest. So 11,000 to 9,000 years ago, we had large numbers of spruce in the area, and boreal pines, fair amount of birch, if we look over here, and towards the tail end of that, a little bit of larch, and we also had poplar coming in at this point. So as things warmed up and changed a little bit, there was a huge influx, massive influx of pines particularly white pine. So in this this large area here, we can see like the column concentrations, like the amount of pollen here, just the jump is almost staggering, like 40, 20, 40, 60% for the amount of pollen grain increase in pines between 9,840 years ago and about 8,000 years ago. Things had warmed up enough that that pine could establish itself. So lots and lots of pine going on. Spruce drops off precipitously. So once we've had pines growing for a while, pines, of course, created their own shade. And somewhere around 8,000 years ago, we start seeing increases in slower growing boreal species like hemlock, so that like things kind of cooler and wetter. It also means that the environment around the year 8,000 had gotten cooler, at least in terms of the ecosystems where the pines were. So we have a large influx of pine. Birches start taking off, and between 8,000 and 4,000 years ago, we also start seeing increases in elm, increases in fagus, which is beech, area, which is hickories, and maples, ash, ironwood, and other deciduous trees start coming in. So this area here, I guess what they're calling pollen zone 4, 8,000 to 4,000 years ago, there was a warming period when mean annual temperatures were actually typically between 1 to 3 degrees warmer than they are now, which is a little bit ironic because we're, conventional wisdom is saying that we are headed that way again. There was also a cooling period after about 4,000 years ago, and around the same time, around 5,000 years ago, just to give you one example, there was a precipitous drop in pollen grains of hemlock. We don't know what killed off this or what caused this massive die-off of hemlock around 5,000 years ago. Presumably insect or disease of some kind. Either way, that's what happened. And the hemlock, by about maybe 1,500 to 2,000 years ago, you can see sort of a slow recovery taking place here in the more recent past. So I wanted to mention that just to give you an example that, the kinds of, when we see species decline, it isn't always our fault. And we are not always to blame for the kinds of changes that happen. And if you look at the change in abundances and variety of species over time, you kind of get an idea that, changes in landscape plants has been going on basically since the day the ice left. This is nothing, in and of itself, is nothing new. And that we've also had kind of this mixed wood forest of combination of Carolinian and boreal species has been here also for, quite a few thousand years. Now, of course, since Europeans showed up, we have also had our influence on this landscape and the vegetation communities, not the least of which was logging on a fairly massive scale, both to produce timber, the vast majority of which ended up being shipped downstream via timber rafts to Quebec and Montreal, where it got loaded onto ships and sent to Europe. There, of course, was in the late 1700s, we had the American Revolution, and we had settlement beginning in this area as well. So in tandem, logging came along kind of in tandem with that. Again, not only for the sake of harvesting trees, but also simply to clear land in an effort to try and, to grow some crops and stuff around here. this area here, the Thousand Islands, yes, the French were already in Canada by this point, but the French never really settled here. They moved through the area. The Thousand Islands, the St. Lawrence River was part of their trade network, but we didn't really have any large-scale settlements going on. There are sort of oral accounts of a native settlement, but we have yet to find any evidence of any sort of more permanent settlement on the native side as well. So natives like the French may have used the area for hunting and foraging and that sort of thing, but no permanent settlements. The closest we might have had to something permanent here would have been Fort Frontenac, established by Champlain in what is now Kingston. So, in the last 100 years or so, we have had some changes in the species composition. Chestnut decline was pretty significant, as was elm decline. And now, perhaps most recently, I guess we can add ash decline to that list as well. So there have been declines in some species, but as I mentioned with hemlock 5,000 years ago, these things do happen on their own as well. And nicely enough, if we can use hemlock as an example to give us some optimism, things don't necessarily decline forever. So nature has incredible capacity to bounce back, and species can do that. Of course, another thing that's happened since Europeans have arrived is there's been more invasive species, things that not only are non-native to the area, but actually intrude into forest ecosystems and can change their composition. So I think 3 examples of ones that are having pretty significant impacts on our forest communities would be things like, and are outcompeting native species would be things like garlic mustard, dog strangling vine, buckthorn, Norway maple, and black locust. Alrighty, so by talking about the plants of the area, this brings me into the topic of biodiversity. So biodiversity is basically a concept of species, plant, animal, etc. And we're talking about species richness and abundance, so the number of species and the relative numbers of each of these species. And for that, this area is actually extremely special. There is some consensus that we believe, we don't know yet, because it's very, very likely that we have not yet discovered and described and confirmed the presence of every species that actually occurs here. But like I said, there is some consensus that the Thousand Islands area is very likely the most biodiverse on the whole continent. No, because of this species richness and abundance that we have here. I touched on this. I don't know if how many of you went and checked out the link that was posted along with this event to a natural heritage review I wrote back in, long time ago, now back in 1995. One of the things that this particular talk, as I was putting it together, has prompted me to do is I looked at this, I went, wow, next year it's going to be 30 years since I wrote that. And if you look at the web page for it, you'll find that it is a decidedly old school web page as well. So next year, for the 30th anniversary of this thing, I promised myself I'm going to update it and update both the internet side of it and make the page look a little more modern, and update the information on there. For this talk, I've gone so far as to make an attempt at updating this aspect of it, the species richness. And to do that, I referred to a project that I created on iNaturalist. So here we go. You'll see in this box here of a pair of these critters, you'll see two numbers, 44 and 40. So these numbers come from the total number of species in my Thousand Islands ecosystem project that collects observations for this area on iNaturalist. So the bold number is what iNaturalist calls research grade observations. In other words, an observation of a species that includes the important metrics like the location, as well as the date and time, date more particularly, date, location, who the observer was, and what was observed. So we actually have a species level identification of the organism, and through other users on iNaturalist, this observation has been confirmed by at least one other user, rendering it what iNaturalist calls a research grade observation. So the bold number for the Thousand Islands in my project, there are 40 species of mammal for which there is at least one research grade observation here. In terms of other observations, we actually have, according to the total count of mammal observations, we have 44. And these numbers are literally hot off the press. This particular page that I'm showing you right now here, I literally just put together this morning. So 44 mammals, according to iNaturalist, there's 44 mammals occurring in the Thousand Islands. If we looked in my old report, we'd see I had the number as over 50. But there are species that were here once but have been extirpated from the region for one reason or another. Those extirpated species include things like moose and wolf and others, perhaps other wildcats as well would be some examples. Virginia opossum has also been extirpated from the area, but that's perhaps most likely to become species 45 because we've already had it in Kingston. So technically, I guess maybe we should already include it. Anyway, all right, so 44 species of mammals, 40 of which have been confirmed to exist recently. Next up, we have, almost getting close to 300 species of birds. On iNaturalist, 276 of which represent research grade observations. I think there's a species list for the park that's actually over 300. So, we should actually think of these numbers that I'm showing you as being, in every case, conservative. In some cases, there just hasn't been an iNaturalist user who's posted an observation about something, that could even be relatively common on the landscape. In terms of fishes, so we've got somewhere around 50 species here. I projected these in my earlier paper from 1995 that there could be as many as 80-odd species here, but currently on iNaturalist, 45 research grade species confirmed, 53 species in total, at least, like I said, on iNaturalist. Amphibians, this is a taxon group that includes frogs, salamanders, and toads. This is where the total species in my iNaturalist project and the research grade, confirmed species actually jives. There are 17 of them. Next up, reptiles. So again, 18 species here in terms of observations collected, 17 confirmed. Reptiles doesn't just include our snakes, that's a rat snake pictured there, but also includes turtles and Ontario's only lizard, which is most definitely found here as well. The next group is mollusks. So mollusks includes bivalves, snails, slugs, and what in another part of the world you might call seashells. So 25 species of those have been our research grade in my project. By far the largest group, not surprisingly, is the arthropods. So arthropods includes, well, kind of non-insect things like crayfish, millipedes, centipedes, arachnids like spiders, ticks, mites, and of course, insects themselves. So well over 3,000, definitely over 3,000 species recorded for the area here, well over 2,000 of which have become research grade observations. I can just give you one anecdote to that. I ran a moth light here for several summers. Incredible fun that is. Everyone should try it. But I have confirmed just at my own property here in LaRue Mills, well over 700 species of Lepidoptera alone occurring in the Thousand Islands. And that is, like I said, that's just at my place. And I think if I ran the light longer, chances are, eventually I'd find some more. But collecting these kinds of observations in one location is a little bit like, collecting hockey cards, right? The more you get, the harder it is to get the remainder. Got them. Oh, need them. Haven't got them yet. All right, next taxon group. Here we have the fungi. We need to remember that the fungi includes not just the polypores, the shelf fungi, and of course, tons of other mushrooms that we see out there, but it also includes all the lichens. The lichens are actually two organisms in one, a fungus and an algae, but they are, in terms of binomial classification as a life form, they are classified by their fungal component. All right, so 447, almost 450 species confirmed for the area, and almost 1,000 species have been observed. Last up, instead of just giving you a plant number, I broke down my stats by monocots and dicots. So first up, the monocots, or what are the monocotyledonous plants. So this is things like our grasses and our, what else is in there? Sedges. So 234 species confirmed, 316. Not an easy group to deal with, not a lot of experts. Final count, if we actually were able to tabulate everything, and I would bet that is higher than what we've got here. Dicots are a little bit more, so this is in many cases a lot of our flowering plants. So this is where most of our trees fit in. But again, so we're talking almost 1,000 species. And again, there's probably more. I'll give you one anecdotal statistics. It was one that I learned back in the 90s, back in the day when I used to be a naturalist for what was then St. Lawrence Islands National Park, now Thousand Islands National Park. There was a comment that we had heard as a botanist had come out and had identified over 30 species of blueberry on a single Thousand Island. That island having been Stoven Island down by Brockville. So here's the total count from my biodiversity of the Thousand Islands project on iNaturalist. 6,068 species, 4,283 of which have been confirmed by at least one research grade observation. And these numbers are all based on 116,600, almost 650 observations. And of course, that's a number that's growing every day. Next year, when I update this thing, I'm going to refine the boundaries of this Thousand Islands ecosystem. And one of the other things I'm going to do is I'm going to go back into do some research of my own and with Parks Canada studies and see if we can't find some more precise numbers. I can guarantee you a lot of these numbers are higher than what we have here. Like I said, this is basically just limited to what iNaturalist users have posted. So what does this demonstrate? It demonstrates an incredible amount of diversity in terms of species richness and abundance. But how does it happen? How did we get here? This is also this abundance has been reflected in the native name for the area, Manitowoc, which I'm told translates to something called Garden of the Great Spirit. The First Nations in the area also have a story of how the Thousand Islands get created. I'll leave that one for you to find out, to read up yourselves on the internet. So, but that name of Manitowoc is a reflection of this tremendous diversity in terms of species that we have here in the area. I tend to think of the Thousand Islands as the Galapagos of the North. They really are as significant as the Galapagos, perhaps not for the same reasons. Obviously, the Galapagos were the inspiration for Darwin's theories on natural selection. However, what do we have here? Not just are we dealing with 1,000 ancient granite mountains, these 1,000 ancient granite mountains and 1,000 stepping stones for migrating wildlife, we can also look at them as 1,000 slopes and aspects. So 1,000 microclimates. Looked at from the top, each island is surrounded by an ecotone. So an abrupt ecotone, and we could think of them also as 1,000 shorelines. On the land, this translates as well. Agriculture, as I said, has been relatively minimal. And in this case, human activity has probably, I would argue, has actually in some ways helped the environment. Land clearing, there isn't a lot of this, things here do not look like southwestern Ontario. We have very patchy clearances, and this has actually, I would argue, increased the amount of edge or transition zones and or ecotones even on the land area. So while we might have 1,000 shorelines on the water, we've got 1,000 forest edges on the adjacent mainland. And again, though, what this means is besides Habitat A and Habitat B, we have all these transition zones, all of these ecotones with this large variety of areas that are cooler and wetter versus warmer and drier, leading to a great amount of habitat diversity. And the greater the amount of habitat diversity you have, this begets a greater amount of plant species, plant communities, and the greater your plant diversity, well, that just begets a greater amount of animal diversity. So essentially one thing leading to another. If you want to delve into some more information about this, here's some places where you can start. Frontenac Arch Biosphere Reserve website, Parks Canada's website, and a couple of my own natural heritage review and the Thousand Islands Island Insight series and the iNaturalist project that I mentioned. I'm going to switch screens here for a sec for us. So Frontenac Axis webpage has some information about well, partly why there's a biosphere reserve here in the first place. Oh, this thing's going to have to move that out of the way. There's what my natural heritage screen looks like. Like I said, kind of an old, very old website, old web page, but I promise I'll be reviewing it next week. Another thing that I did was I translated, or at least made virtual versions of a series of papers or small little booklets that were produced by Parks Canada in the 70s. So these are also available on here, and particularly with respect to geology, there's a lot more information if you want to do a deep dive into that. You can find this information online as well. And here we go. There's what my iNaturalist project looks like. And
Oliver,
there's our yes.
sorry to interrupt. We can't see your other screen. You're just still sharing the PowerPoint.
Am I?
Yeah.
Oh, okay. Sorry. That's good to know. All right. Let me go back to that then. All right. Well, sorry about that. All right. And I just realized that according to this thing, I've been talking really, really fast, and apparently it's only like quarter after. All right. Well, more or less to sum up, what I've talked about so far here is how did we get all this diversity here in the Thousand Islands? We essentially have a unique geology through the Frontenac axis. We have a migration corridor that facilitates a tremendous amount of species movement, and also did so in the past. We have a moderated macroclimate because of the lake effect of Lake Ontario, or lake effect is what they call it. We have a tremendous diversity of microclimates due to the rolling topography and, of course, the islands in the river. That rolling topography leads to a large amount of habitat diversity for plants, which creates a lot of diversity for animal creatures. And of course, the more habitat diversity you have, the greater amount of diversity you have with respect to the ecotones or transition zones between them. Now, this, as Chloe mentioned, this is being put on by Little Forest Kingston. Little forests are these little patches that things are trying to grow. Let's look at little patches here for a second. And I thought I'd finish this just by looking at a lot of times when we look at, yes, we're trying to protect species. What we tend to do is we tend to concentrate on habitats. Yes, we need to preserve habitat because if you don't have the habitat, you're not going to have the species living in there. But the habitat that we are preserving, or in many cases, if we are restoring habitats, there are good ways and also better ways with which to do it. And this is where I grabbed this picture. This is, if you go to Wikipedia and look at how they describe an ecotone, they give this example of ways that ecotones or transition zones can manifest themselves. We all know, so if we look at A to B in the top left corner, we all know that the shortest distance between 2 points is a straight line. Well, that is actually from an ecology perspective, we could say that represents the minimum or least amount of interface between those two communities or those two systems. And what we can learn from that, or what we imply from this, is that if we want to have a more enhanced, or have better efforts at habitat restoration, we can focus on, or should maybe put a lot more effort into enhancing the ecotonality of an area. So instead of having a rectangular little forest, maybe we should be considering doing something like this, because every one of these gives examples of areas where we have more edge or more interface than we have in our top left box here. Perhaps an easier one would be to just have more wavy lines or paths running through them. But any way that we can improve the amount of interface, or the amount of ecotone, or the amount of forest edge, or whatever we want to call it, on the landscape, we are creating opportunities for more habitat diversity and more species richness and abundance. So for those of us who are landowners, this is something that maybe we can take to heart and keep in mind if and when we are planting things or we are trying to rehabilitate landscapes, whether it's on a small scale or even a larger scale with our tree planting. Monocultures, not so good. Diversity of species, good. Diversity of habitats, better. Diversity of habitat with a large amount of ecotone between them, probably the best. And that's more or less what we have here in the Thousand Islands. And that's why they are the Galapagos of the North, and they are Manitowoc, and why we have all of this diversity that we have here. And that is more or less what I was willing to share with you today. So ending things on a happy note. I'm just going to say thank you for listening to this. I know that there was I talked pretty fast, and I think I probably shortened the amount of time that I thought I had, but that's okay. We have opportunities to ask questions. I know I've covered an awful lot of material, and if you want to go into a deeper dive into a lot of it, like I said, there's definitely more information out there. Start with my Natural Heritage Review. Go with those Island Insights books. Maybe I would also suggest maybe checking out Parks Canada's latest ecosystem management plan. There's probably some more up-to-date information on there than what my website has at the moment. For example, Frontenac Arch Biosphere Reserve site should certainly have more up-to-date information as well. If you can find an older book by on St. Lawrence Islands National Park, a guide that was published by Don Ross back in the 70s, that one has some decent information in it as well. So certainly more out there for those who are keen to learn more. Anyways, thank you everyone for taking time out of our collective family day long weekend to listen to this. I hope it's been interesting and educational for everybody, and most especially to our forest wranglers, whom I would personally like to thank for all the work that they do with respect to the little forests, and to Chloe I'd also like to thank Chloe for prodding me into providing, something that gives us as the managers of the little forest, as a way to thank the volunteers who come out and help plant them and get their hands dirty. So again, thanks to everybody. And I guess at this point we can open things up to questions.
All right. Yes. Thank you so much, Oliver. That was very fascinating. And a lot of people are writing in the chat. And so I will just read through some questions, and I'm going to take them slightly out of order because there are some that are on the same theme. So the first one is from Roger, and he says, why do we assume that temperature requirements, for example, oh, I just lost the chat, just a second, find it again. Okay. Why do we assume that temperature requirements, for example, of plant species shown by pollen profiles have not changed/evolved over time and might not therefore reflect climate change?
Okay, sorry. I've just closed the screen there. I'm not sharing it anymore. I'm a much better at learning things with. I'm a much better visual person than anyone, so I'm just going to read this question myself to make sure I understand it. I've got the chat window open here as well. That's a good question, and I think from my 2 cents, I think all I can think of is that some of these changes, plants will change and adapt. the trick though is some of them do it over much slower time. Like, for things to change their essential habitat requirements, yes, they can adapt, but those changes, my guess is that those need to start happening at the genetic level. And genetic changes really only happen over time and over multiple generations. So while it's certainly possible for plants and animals to adapt, like I said, these things need to happen over time, if they happen. In some cases, it just won't.
Okay. And another question just on that same sort of topic. Joyce asked, might the species that were fairly consistent in the pollen samples be the ones that are more resilient towards climate change?
Yeah, there's, my own view of these pollinators, like I said, we do make assumptions about that. We make assumptions that just based on the abundance and types of pollen that are there, that these were the prevailing vegetation communities at the time, and also therefore the prevailing climatic conditions at the time. They are not the only things that affect that, though. Like I said, insect diseases, natural disasters, disturbances can also affect these populations. And for many plant species, we simply don't have information, or we don't know why they don't necessarily appear in there. Perhaps there was a population boom of a grazing animal that ate them all and extirpated a species.
Yes, that makes sense. Okay. Okay, so then there's a couple questions on this slide that had all of these species, the pictures of the various types of species and the numbers. So the iNaturalist project. So one question is, Christine asked, when you consider 279 species of birds, are these only those that are permanent residents or breed in the area, or does it include birds that migrate through the area?
As far as iNaturalist goes, you can't really make distinctions, or break things down that way. You can literally only break down your project by taxonomic groups. So that's for all birds that have been entered into that project. So it's a combination of both year-round residents and migratory species. I can tell you the Parks Canada species list is over 300. So not everything that conceivably occurs here has been included there. And there's also, occasional what they call vagrants, things that get kind of blown off course from way out east or from further south. Or sometimes there's even what we would call sort of there's even probably potential for the odd species of thing that really doesn't exist here. It's like somebody's parakeet escaped, and then you go and see it in a park. It's very likely that the current, mammal list, probably includes a dog and a cat as well. But you can filter that stuff out by using sort of, by filtering out captive species. One thing that can I tell you about the bird species is that one thing that is known here is that out of the number of species of birds that are known to breed in Ontario, the largest concentration of species that are breeding in Ontario, that greatest concentration is here in the Thousand Islands. And it is over 200 species, if I remember correctly.
Cool. Okay, and then just on that same note, Kim has asked, is there a list available of these? Like, where could you go to see a list of all of these species?
A couple of places. I would think I would say the most up-to-date list for species from this area. We can either talk to Parks Canada or the Kingston Field Naturalist. There must be a birder who would have up-to-date species list. Charleston Lake probably has one that's fairly current. I created species lists myself and there are links to those. Actually, if you can find a link from Parks Canada to them. I updated them to, at that time, which would have been back in the mid 90s. So species lists are not something that are carved in stone. Species get subtracted as they go extinct or become extirpated. Species are added as they get introduced or expand their range.
Okay.
So anyways, if you type Birds of the Thousand Islands checklist and my name, that would take you to the species list that I have from the 90s. Chances are they're a little bit different now, but like I said, there's the local field naturalist groups or a provincial heritage organization would probably be your best bet, at least for this area. If you're looking for a province-wide list, the NHIC, the Provincial Natural Heritage Information Center, they're probably your best source for a current list of the total species in the province. And that goes the same for other taxon groups as well, at least in terms of macrofauna.
Okay. All right, I'm scrolling through. There's lots of thank you Olivers in here, which is great. Okay, and then Debbie asks, is fire a component of your disturbance regime on the Thousand Islands?
Yes, traditionally, if we go back in time, yeah, fire was very much a natural component. We know for sure that it is a component of the boreal forest. Jack pine being one example. Once you have a fire, things get, it's considered in terms of natural ecosystems, it is a disturbance. It is a natural component of many ecosystems around the world. When I was in college, I had an entire course in forest fire science, it was called. It turned out we didn't really learn a lot about fire itself. The course was about, forest fire science is 80% weather. It's 80% based on meteorology. The weather index that they put up, whether there's a burn ban on or not. What they're monitoring is moisture levels. The drier things get, the higher the forest fire weather index. The behavior of fire is also very much weather driven when there is a forest fire. I know this stuff is top of mind because of what happened, last year. But yeah, fire was a natural component here. One of the things that I learned in school back in the day was, this is a good statistic to remember, 90% of all fires are caused by lightning strikes. So, natural. A further 5% of lightning strikes are caused by sparks from railway tracks. We go back a few years, and I really don't remember whether this was in the 90s or in the early 2000s when I came back to the area. There was a sizable fire in the marth of the Cataraqui in Kingston, right around where the 401, crosses the Cataraqui River. I don't know if people remember that. I don't know what caused that fire. I'm not sure anybody ever does, but hey, there's a railroad track right there, so good possibility a spark caused it. But like I said, the vast majority of forest fires are caused by forest fire, or are caused by lightning. Second greatest is train track sparks, and things like your careless camper and smoker. They actually represent a very minor cause. So they are a natural part of the system here. When humans came along, yeah, intentionally creating fires to clear land. Yeah, that was a practice by both the Loyalists, early farmers, and by First Nations people and their agricultural efforts. There was also some land clearing. So fire is a natural component of the area. In some cases, fires get started intentionally. For Parks Canada, for example, for people whose responsibility, or organizations whose responsibility is to restore or maintain natural ecosystems, prescribed burns are a viable and a long-established and well-known tool in the restoration ecologist toolkit. I think somewhere, if I remember right, within the last 20 years or so, Georgina Island, which is one of the Parks Canada islands that the Thousand Islands Bridge goes over onto, prescribed burns were done there. And I think historically there's also been prescribed burns have been done on Hill Island as an effort to naturally help restore or recreate habitat for pitch pine. So just a couple of examples. There's also been research done on the prevalence of forest fire in the Thousand Islands. I don't know offhand a source for that reference, but I do know that there was a researcher who did come around here around 2005, 2006, and we toured her around, and I helped cut down some trees for her to collect, for this researcher to collect cookies and to look for fire scars in the tree rings. There's a way to determine both the frequency and the severity of forest fires on the landscape here in the Thousand Islands. So some research has been done on that.
Okay, great. There was just one, and just before we get to the next question, there was a comment that says, iNaturalist does let you see time of year graphs for species. So I'm guessing you could see migration based on when observations peak. Okay, so another question by Rebecca is, how can you connect efforts of Little Forest Kingston to your last point of creating more edges to promote diversity?
Oh, great question. I didn't really give a good sort of personal example of that. Now, I know, when humans, when we carve up the landscape, we tend to do it in rectangles. When fields get cleared, it tends to be sort of tracts of land, also tends to be in rectangles, or very much where straight lines are involved. And I'm going to guess that probably some of our little forests that have been planted in Kingston are also just quadrilaterals of one shape or another, because they need to fit into, square, rectangular shaped landscapes. Would that be a good assumption to make?
Yep.
Because I admit I haven't visited any of these. I think I've driven by a couple of them, of our little forest sites in Kingston. Is that correct, Chloe?
Yeah, I'd say we have a mix. I mean, at some sites where we have more space, we might have 3 sort of generally rectangular forests side by side, so that at least they're incorporating that kind of path concept. But I don't know if we've ever consciously tried to maximize the edges. So that's definitely not something we've thought about. So it's very interesting.
Right. So a practical application of it would be, okay, if you're looking to cover as much space as possible with little forest species, then, you probably should fill out your rectangle, but you're not necessarily creating the most edge that way. So instead of a rectangle or a square, or about the only thing that a rectangle or square is better than in terms of creating edge is a circle. If you did a perfect circle if it did a perfect circular plot, that would be literally the minimum, geometrically speaking, of the amount of edge that you would have. Now, if you want to maximize the amount of edge, instead of a circle or even a rectangle or a square, lay it out in an amoeba-like blob. Sort of the wavier your lines, or even go zigzaggy if you want, or have a wavy, snaky path through the middle of it. And now you've created kind of a long, skinny clearing, which is basically what a path is, at least at a microclimate and level of for smaller species. So, I mean, traditionally, if we look at 2 just classic examples of edge, if you're a bird watcher, yeah, along the edges is where you're going to see stuff. You're going to see stuff along these trails, not just because that's where we frequent ourselves. And yes, observations on iNaturalist and in ecological inventories, a lot of times they're concentrated on where humans habitate, right? Oh, we see a lot of things here. Well, that's because that's where our paths are. or we see a lot of things along roads. Well, that's because that's where we are. We're not always in the middle of nowhere where the ecology is still going on. So, and the same thing applies on a small scale in a little forest. So yeah, practical application, just vary the shapes of your little forests so that you're creating more wavy lines or more edge to it. In a sense, the more the better.
All right, awesome. Okay, and then Rebecca also asks, what are the dates for the existence of Admiralty Lake and Champlain Sea?
Let's see. They think the last ice age, 20,000 to 15,000 years ago, around 15,000 years ago. I mean, these numbers are just generalizations. You know, nobody has this down to the exact year. And when we do the pollen grain studies are done, and the aging of that is done based on carbon-14 dating. So radiocarbon dating, no different than the way we date bones, fossils, that sort of thing. So we know the Laurentide ice sheet, like I said, so 15 to 20,000 years ago, ice started retreating. We had the glacial lake, 12,000 years ago, the ice had receded. There was glacial meltwater, so which presumably was to some extent, somewhere along the way, we had fresh water and salt water started mixing. Eventually, it became entirely fresh water as the Thousand Islands area became basically the outflow of the entire Great Lakes Basin. So in terms of specifically, I'm getting confused here at the moment because they call this thing sort of the Admiralty Lake, because there's this group of islands called the Admiralty Group, and I'm not sure that there's necessarily a congruence between the two. So I'm hoping that kind of answers the question.
Okay, and then does iNaturalist also list the grasses and vegetation? Are these located under a guide tab? So I guess the question is, can you go to iNaturalist and see these lists there? I'm assuming.
Sorry, can you repeat that question? Oh, sorry, just let you see time of year graphs for species. So iNaturalist, one of the things, one thing I want to tell everybody about iNaturalist is there's a huge difference between the app and the website. The website is a fairly minimal thing in terms of the functionality of it and the kind of information that you can gather and amalgamate. The website has way, way, way more functionality and things available to you than the app does. All right. For example, one of the main things that they do on the website is they've added annotations, which are things that they do to fill in information on, because every species has its own sort of profile page within iNaturalist. Yeah, they go and they borrow the write-up on it if there is one from Wikipedia. They use various taxon lists to create the taxonomic table and give us the latest taxonomy on it. But you will also see things like life stages. There's annotations there that for the information that's there, you are encouraged to tag a plant picture with, like, say, well, okay, what stage is the plant in? Is it which picture of this plant was used to corroborate it? Is it a picture of the fruit? Is it fruiting at the time of year, that the observation was made? Is it flowering? Is it fruiting? Is it doing neither of the above? Is it even in leaf? Are we just seeing a twig? Obviously in January, the only things that are going to be in leaf are the conifers, with the exception of tamarack. So for animals, for example, all right, we have a species of butterfly here. We know that it is a monarch, but, is it the larva, or is it the pupa, or is it the adult? we may know the species, but iNaturalist, because it's also collecting time of year information and where people put it in time of day information, if we add an annotation about the life cycle, about the life stage of the animal, the more observations that do this, iNaturalist is also becoming a repository. Like it's basically trying to turn itself into every field guide ever, with basic information about every species and what its life cycle is. Some cases in a lot of cases, the site is limited in terms of the superficiality of the type of information that we can upload. You're basically stuck with showing it pictures or sounds. And there are many species where we simply can't do that. You need to have to dissect the animal to determine the species, or you need to do DNA analysis on it. Or sometimes you just need to come back a different year when the diagnostic feature is available, because some diagnostic features aren't available year round. So so what I encourage people to do, instead of just putting observations on there, is avail yourself of these annotations. The more people include information about that, is the more we will include, we have information about the life cycles of plants in the area. When are they flowering? When are they not? In terms of animals, when is the adult form available? Time of year is like for some species of moths, the only way we can tell them apart, like two species of hummingbird moths. There's two species that look exactly the same. The only way to tell them apart is the time of year that the observation was made. If they were done in August, it's one species. If they were done before August or after August, it's another species. And again, like I said, this applies to flora and fauna equally. And the more people fill in these organizations, the more accurate those tables and information will be on the species profile page on iNaturalist.
Okay, and it's getting quite late, but there's just one last question here. And so it's just a continuation of the idea of little forests having lots of edges. So Joyce just says, plus I'm assuming taper the edges of the little forest with shrub layer, then meadow. So is that what you're recommending, that at each edge you would taper it, where you go from tall trees to a shrub layer and then meadow?
Yeah, it's a good way to start. It sort of gives succession a kickstart by having various stages in there, right? And of course, you're also diversifying your habitat in terms of animal users. At the start of a little forest, obviously it's going to be more microfauna than macrofauna. We don't actually want a macrofauna around because they're more likely to start foraging and and eating things that we don't want to have being eaten, that early in the stages. Like we don't want mice chewing off the bark of our saplings, right, or seedlings. The other thing is one other way to do it, instead of planting, like Joyce was suggesting, a variety of sort of trophic layers of vegetation. Yes, that's one way to do it. Another way would just be to not fill the entirety of the space with plants. Leave a gap in there where you've just got some dirt. It might just be a dirt where, that would allow people to walk through the middle of this forest and enjoy it that way. But that in and of itself, that path would create an edge. And the ongoing disturbance of people walking through it would actually create a different, floral regime right in there as well. A lot of times you'll notice if you look at like a trail, like, I don't know, your hiking trail in a provincial park, for example. Sometimes you will see grasses right next to the trail. Grasses are an early stage. They are also a good indicator species of disturbance, which, human footprints, everybody stomping along a trail actually is. So you will see those grasses on the edge of the trail, but as soon as you get into the more shaded area and you get further away from the trail, suddenly those grasses disappear. So you've even got a little, like I say, you've even got these little trophic levels going on kind of right there. But as I said, there's, gaps are perfectly normal. It isn't necessarily normal to have everything covered in trees. You know, obviously forest fires do large scale landscape clearing, but smaller examples of clearings in the middle of the forest happen as well. A lightning strike can fell a tree. A microburst can lead to blowdown. Something like the Derico that happened last year will just, you know, create a strip of deforestation across the landscape. And again, plants and animals don't necessarily mind this. It just, you know, you're not getting rid of stuff. You're just replacing one kind of habitat, one kind of moisture and light regime with a different one. So yeah, a little forest on its plot can do that sort of thing as well on a smaller scale.
Okay. All right. Well, it's almost 9 o'clock actually. So this has been wonderful. So much information in this session. And thank you, Oliver, for putting this together and for all your thoughtfulness and answering questions as well. And thanks to everybody for coming and engaging with this material. Very exciting to see you all here. And you can always reach out to us if you have any more questions or anything. We'd love to hear from you. And otherwise, we'll call it a night and hope everybody has a good night.